The topic is generative AI for enterprises. So it's the there is enough already that we discussed since morning, maybe since yesterday, on generative AI, and you might be wondering what different or new perspective that I'm going to bring, and I'll try my best. But as the topic suggests, I want to focus Gen AI, what it means for us and our customers. That is going to be a core theme because when we go online, maybe watch videos, read material, a lot of it covers different aspects of Gen AI. And I just want to make sure that what I talk about is from a perspective of an organization, business, or enterprise, how we should look at Gen AI. And I hope the perspective that I bring would help us in business. Right. Right. Okay, so quick introduction. This photo, by the way, at at the caves, Batu Caves, right? In Kuala Lumpur yesterday. So this is basically our, yesterday Frederick mentioned about nomad, Mongolian nomad. So it's basically, we are technology nomads. What that means is we look for paradise in technology landscapes. That's really what we love to do. We find something, we settle there, we play with these technologies, and for us, what paradise means is actually creating impact to people, businesses, through the least effort. And that is the sort of sweet spots we look after, like how can we create sort of high impact with low effort. And currently, as you can see, we are settled in this new village, Gen AI, for last close to 18 months. So 18 months means the point is well before ChatGPT became popular. We started when GPT-2, GPT-3 were there and played with those versions and saw the potential. And in this 18 months, we actually got opportunity to work with, or at least discuss use cases, almost close to 100 clients, because I just did a quick math. Every day we talk to at least a couple of clients, one or two clients, and that has been going on for last more than 100 days. So what I want to bring to table is what we learn with that experience. So quickly, my role at Accion is Chief Solutions Officer. You know that Srijit, he's basically the core technology brain. So who sort of, when we get an idea, he plays with it, get to the deep depths of technology to solve problems. And Bharadwaj's job is to just make sure that we are grounded. We don't go too far down the rabbit hole when we play with such interesting or powerful technologies, and bring the customer perspective and the customer use cases at forefront. So that's Bharadwaj, who bring that business and customer angle all the time to keep us controlled. Right. So this is the time when I don't have to explain why Gen AI is the elephant in the room. But what is important is it is the elephant in the sense that when all of us or many of us talk about Gen AI, we generally tend to look at some parts or some aspects of Gen AI and think that is a Gen AI. And again, that perspective or that view I have based on my discussions with so many people and so many customers, and after hearing their use cases. And you can hear even when it's panel discussion or generally we discuss, everybody brings new perspective. And that is good, but that is also a problem. And I'll tell you why that becomes a problem. Especially in an enterprise setup, the decision making is not done by a person, but group of people. And what we often find is that because of this different perspective, and rightly so, this is really upcoming technology and people have different views, their views at times are not in sync, which makes the decision making difficult. So if you see, So that makes the decision making difficult, uh, and which creates that gap between when we see something at the hype cycle, but we always get concerned that why it's not creating the impact when it is at the top, and the friction of enterprises adopting this potential that everybody sees comes from that. And what one of the approach that we recently do when we work with companies is to sort of get the whole leadership aligned to a certain view. And what we generally talk in the workshop, that is also partly what the thought process that I'm trying to explain here. So what is the reason that we all seems to be having different perspective of views? And this is one of the reason where when we look at GenAI, it has like many dimensions, and we need to be clear of, as an organization, what is our role. And if you see, like any other technology, maybe automobile, electricity, computers for that matter, there is a sort of a group of people who are basically inventing that technologies, writing new papers, doing research, and actually bring that technology to use. And that gets very complicated very quickly. If you say, for example, let's say a computer. So we all use computer. That's basically our bread and butter. But how many of us actually understand how the computers are made, or what is the process, what the wafer manufacturing, and what's the IC chip designing? We don't need to know a lot of it, right? But we still use computer very effectively. And all of us, actually, when we go home, we are also user of computer, right? We watch maybe movies on computer, or we do certain tasks as a computer, as a users. And the same thing is applied with GenAI. And sometimes when we discuss, we get confused between our role. Is our role as an end user? Like I use ChatGPT. So many times when we ask companies, okay, are you using GenAI? Are you doing something with GenAI? And I said, oh yes, for last maybe 9 months ago, we had ChatGPT got implemented, and we are doing a lot of things. But what they don't realize is that using Copilot or writing, giving Copilot to the developers and adoption of GenAI technologies is very different from creating solutions using this technology. At the same time, creating solution using GenAI is different from actually building or creating models, large language models. And this is a very common confusion. I heard like one of the largest bank, and their CEO was saying that, oh, actually, you know what, we are building our own LLM. We don't want to use third-party LLM. We are concerned with data. And those kinds of views concern me, because there is a fundamental distinction that isn't been made. Whether are you a company that solves problem using GenAI, or you creating models and becoming like an inventor of AI? And this is pretty heavy. We cannot like lift a weight of being an AI inventor, because then you are competing with OpenAI or Anthropic, these companies who are like spending their core attention and bandwidth into building this model. So it is very important to understand our role is how do we use GenAI. And unfortunately, if you go out means on internet, the discussion about using GenAI in an enterprise setup is not the topic either of interest or deeply covered. When you go online, you see about material on, okay, what is the new LLM, when the Sora got launched, or yesterday, Cloud new version, Opus got launched, and what they are doing, and their benchmark. So we naturally get either pulled in this direction or pulled in this direction, that new multimodal version got launched by OpenAI and so on. Now, I want to focus entirely on solution building. How do enterprise build solutions? How the landscape, what the thought process needs to be. So sorry about this, could have been an earlier slide, but here what I want you to pay attention to is we all know that GenAI is right at the top of hype cycle, and I think Samir mentioned that the rise of GenAI to the hype cycle. What is interesting to note is what is coming after that. Sorry. So what is coming after that? And you see a lot of these AI technologies. And by the way, this is all AI technologies. And actually, the floodgates are really open. There is so much research happening in this space every week. Really landmark research paper getting written. And this is just the early step in terms of what GenAI technology and capability has to offer. A lot more is coming up. So I think we were discussing yesterday about the ice hockey player, and he said that I don't watch where the puck is, I watch where it's going to be. And what we need to also careful about where the AI is going to be, and build solution keeping that in mind, because today's Gen AI might be seem like little bit flawed, little bit unintelligent compared to what your expectations are, but all those gaps are going to get filled. Means to simply explain like, okay, Gen AI today don't have a long-term memory, because we totally, all the solution that we build is based on short-term memory that Gen AI has. But maybe 2 months ago, if you are told ChatGPT that your so-and-so is your birthday, it won't remember, right? Why is it? Because they don't have long-term memory. But now it's not there, but see, that's the point. Mamba, new architecture that is getting tested and giving good result, has long-term memory. And imagine what will happen when we combine the short-term memory of current Gen AI with architectures that have long-term memory. That's going to be very powerful, just as an example. Right. So I'll give you, you all know, right? But the important point is that AI is not new. Even Gen AI is not new. People in, I think, 1970s played with this next word prediction. Actually, this next token prediction, they started with later and things with some success. But till recently, they were struggling with a long sequences, either in memory or generation of long sequences. That's when it started. It used to go wrong till very recently. What really changed the whole game is this 2017 Transformer paper. And I'll tell a little bit more about it, because otherwise you know all this, is because what part is really important for us as a business. What happened in 2017, the paper, you know, like attention is all you need, they change the approach of neural networks. Rather than using a memory, which earlier neural networks used to do, like separate neurons storing information, what they did is they used contextual information, like how we perceive the environment, that information just as a form of another layer of learning. So rather than storing that information as is and retrieving, it is going to train LLM. It's called like an in-context learning. And that in-context learning made this algorithm work a lot better. Otherwise, NLP was there in 1980, but wasn't very good, because the context wasn't getting learned. Just remembering or retrieving context wasn't good enough. And what we mean by learning the context is that when we read, even if you give a paragraph to ChatGPT, so the words get completely recalibrated and the weights get changed closer to what it means in the context. Like if a word, let's say a bank. Bank can mean a bank to where you draw money, and if the context says that it's about money and person in financial trouble and the word bank, it would know that you are talking actually about a bank and not about a river bank. Whereas if it is about holiday and water, and it will actually change the meaning. That ability made LLM so successful. And why it is important, because it is that ability, and I'll come more to that, is going to be transformational for us as business. Because the ability of training LLM just real time in that context, and today that context is limited, but it's still significant. It's about maybe 16K tokens, which means maybe 100 pages. The ability to train LLM with this 100-page information, learn that in seconds, and give close to accurate answer on that, and we know where the answer come from, is a phenomenally great capability for businesses. And very understated, means it's not understated as a whole, but generally, when we think about LLM, we think about data, training LLM, fine-tuning LLM, but even though that's powerful, as a business, it doesn't help us, which is where our concerns of hallucination and things come from, because when you train LLM, all that is happening is your vast amount of information getting cramped up in a very dense space. So basically, This dense information means a representation of information in a manner that is numbers or probabilities. So it is unable to recreate what is the actual information, what is the fact. And that is the inability of LLMs we consider as an hallucination, and therefore we worry when we implement LLM in business. But what is happening when you train LLM in the context is that it remembers far better, and there are benchmarks to prove that and things like that. But that is the capability that we really, especially our team, focus a lot on. So I talked about this, but training a new LLM, let's just quickly understand what it means, because these words you would come across, like creating a foundation model or creating a LLM with your own data, is actually taking a baby and make it learn native language to speak from absolutely raw information. And that is essentially what it does. And therefore it is slow, therefore it is expensive to get a baby to learn mother tongue takes years, but it is exactly right, like that. It is very slow, cumbersome, and effort-intensive process. So there is a very clever approach to get like a pre-trained model and then fine-tune with your data, which is also kind of cumbersome, slow, expensive, not as much. That is almost like getting a fresh graduate and making him go through 3 months or 6 months training program, upskilling that, right? In both the cases, there is no guarantee that whatever they have learned, they have a capability of accurate reproduction of that information, what we need. That is where my problem with fine-tuning or pre-trained models comes from. Of course, we need them, but we need to be very careful when we use them. It should not be the starting point, but it is when we can't achieve our result with the next approach, we come to them as like a backup plan. Now, what is RAG? You might have, some of you might have, how many of you heard this term called retrieval augmentation, RAG? Okay, good. I see at least about 40%. I like Frederick's approach to quickly count the percentage of hands raised. So that's great. So we roughly know. So for the rest of it, I'll quickly tell about what RAG is. So let's say, take an example. We ask ChatGPT, what is my employee number in the organization I work, or which organization I work? Very simple question, right? Your friend would answer immediately. ChatGPT can't. Why is that? Because ChatGPT absolutely has no context, who you are, where you work, what is your employee number, no access to your database information within the organization, right? There is a very simplest version of the questions that we want to solve in a company, but as a raw model, as a pre-trained fine-tuned model, it would not give you quickly that answer. So what we do in RAG, our retrieval augmented generation, is that we supplement the question with enough information from which the answer can be derived. And this approach is called retrieval augmentation, because what we need to do is we retrieve the context, additional context, from the information that we have, be it a document, PDF documents, or any other content, or even any other information systems that you have, bring that context on the fly, attach it to the question, and ask OpenAI model like GPT-4 or any other LLM model that give me the answer from the context. Don't tell me anything that you learned on internet. I'm not interested. I'm only interested in the answer that you will find in the context that I have provided below. That is the retrieved information that we augment with that knowledge. And I told you earlier that there is an in-context learning happens on that context, and you get the answer. Now, this approach is really very interesting for any organization to build their systems, right? In this, and you will find a lot of examples how people are using it. So people are using it to provide large sort of information within an organization, all the tribal knowledge in the form of documents, and then sort of search those information that you have already indexed. And today we have a very interesting vector stores that we use to index that and search that, very similar technology that even LLM uses themselves. And that gives us this sort of additional context that you would supplement your question with and get the answer.
7 quick time check.
Right. Okay. Now I'll quickly, this is basically what we did is we realized that that's not enough. What other people are doing with RAG is very interesting, but for business use cases, we need more. because our context is the entire information systems. Like you have content, which companies know how to work with, data, apps, other SaaS application, processes, and all that. These are your information assets. And what we need is a smart retrieval engine that can provide the additional context, provide it to LLM, and generate the response. In many cases, the smart thing to do is that the generated response, you can ask it to write code that you can actually run on your existing application. And that is essentially the approach that we take. Now, let's come to the core theme. This is a very interesting sort of comparison of abilities of human versus computers to Gen AI. And if you look at first two columns, and maybe this speed or accuracy and ability to perform repetitive tasks, it is very clear that computers are great at it, which is why we use them in scenarios when we find repetitive tasks. And this is a matrix I want you to pay attention to. So here on the x-axis, we have volume of the same task repeating in your organization. Do you do it 10 times, 100 times, 1,000 times, or million times? And when you do certain tasks many, many times in the organization, maybe a few thousand times a month or million times, you of course need software. And that is what we call automation or write software, so that we don't have to manually do it again and again, because people suck at doing the same task again. They can't scale fast enough. And that is where we use computers when the volume is high. But on the y-axis, we have variety in the task. Variety means different, maybe it's the same task, but you have to do it differently. When we come across that scenario, you have to write another program, another software to take care of that variety. And you can't keep up with that, because what if the variety is very high? What if the variety is so high, like do you have 10,000 varieties but no volume, or very low volume? Would you ever be able to automate? The answer is simple. The answer is no, we don't. What do? We put people and more people as it scales, right? We have no choice. We have no choice till maybe a year ago or 6 months ago. Something remarkably changed because of Gen AI. That is its real power. And the real power is that first time in human history, we have a technology that does not automate what you do repeatedly. That is what all along we did. What Gen AI can do is automate even the variety. In fact, Gen AI is very bad. If you go back, Gen AI is not really good at this repetitive thing. It is very slow, it's very expensive, so you would never consider Gen AI to replace software. Software is amazing. It runs exceptionally fast, exceptionally cheap. You can't compare Gen AI or human with that. But when there is variety and people doing things, all of those things can certainly be automated using Gen AI. That is the perspective. So in fact, this approach, even in automation, they use a lot. Like automation, I mean plant automation and things like that. They call it like a fixed automation, and that is a flexible automation. And Gen AI gives that ability to do this flexible automation. And there are countless examples. Like you can use cognitive ability of Gen AI to sort of, let's say, go online, find right information, click right buttons, get the information that you want. Or you can use Gen AI's ability to write program. It's only the creativity is a limit how you can use Gen AI there. I'll also talk a little bit about some scenarios where we have high volume and also high variety. And these are the complex areas within our organizations where in the past we had teams and we have software that's getting used. Today, we can't really use Gen AI to handle large volume. And the reason is that I told you, like Gen AI is slow. It takes few seconds versus maybe microseconds that computers takes, or it's expensive, like you pay for every token, especially if you're using third-party LLMs, right? But what you can do is actually use Gen AI to write software, and that can take care of this high variety and high volume. And again, writing software we thought is a human thing. Why it is a human thing and not computer thing? Because so much variety. Like for every problem, you have to write a new code. But again, that's probably could be a domain for AI. So I think that's pretty much it. I'll quickly talk about so where we are heading with that is there are estimates about few trillion dollars impact that Gen AI is going to make, and you see why, where it's probably going to come from. And it's not only about productivity gains that we make by reducing human effort. There are like examples where, in fact, we work with some of the clients that things that otherwise you don't even imagine, because when we see organizations coming up with their use cases, as we saw in that first slide, they look at only one aspect of Gen AI. Like one healthcare client we work with, they gave us 50 plus use cases, and most of their use cases is generative capabilities like content generation, document generation, report generation that goes for submission or summarization. That is just one small aspect. And Srijit and Bharadwaj will talk about so many interesting use cases that we have worked over time, like ranging from extracting data, feeding it to the online systems, or generating dashboards and graphs, writing code, and all of that. But this is basically, we can, and you can see high tech right at the start, but where the impact would be, but this is like the billions of dollars impact that you can have industry-wise to see what the scale we are talking about. So I'll take a pause and wait if you have any questions so far.
Thanks, Chetan.
Right, thanks.
A few questions. So how do you ensure data secrecy providing solution using Gen AI?
Okay, how do we provide data secrecy? There are many ways to do that, and we have in fact implemented. And mostly this question also comes from the fear that we believe that Gen AI is in some way sort of use our data. And many people even think that whatever questions we ask, actually AI is getting trained automatically on that. But AI is a very simple, like Gen AI, it's a very simple machine. All it does is, it has seen a lot of information, and as I said earlier, it crunches them into a very small vector space and represent it by certain numbers. And it's a very slow and expensive process, which means retraining is not going to happen often. You have seen in ChatGPT, for a long time it was shut till 2021 September, right? Why wasn't it updating itself? So there is no ability. These are actually stateless machines. They don't look at their data. When they look at it, they can't remember. That is the fundamental problem with AI. They cannot remember anything, and let alone accurately remembering. But still organizations are concerned. Why? Because when we talk about Gen AI, most important aspect that we talk and which differentiate it from all other predecessors of AI is that it has to be externally developed. It has to be trained on information that is outside your organization walls. Right? ChatGPT trained on whole of internet. These are large models. They require a large amount of data, which means that in some way you are actually dealing with an interface with external company, and that's where the question of data secrecy comes from. How do you handle it? Now I'll come up with some of the solutions. Like number one, if it is data, what we generally do, if I go back to the architecture diagram, but I didn't explain, Srijit will probably explain in details. We do a very clever thing, which is we don't expose the data, because it's not just for secrecy reason, but for many other reasons, that we have generally too much data to fit it into context and things like that. What we do with AI is train LLMs on the schema of our data, and that is more than enough, right? Because with that training of schema, LLMs can give us accurate queries that we can then run on our environment. And that is a very powerful thing, because actually AI hasn't looked at our data. All they have given us is a query back, which we will run, and the queries are powerful because I can be sure that they give me accurate result. So I don't worry about AI making up answers, and people think about, it's a mission critical thing, I need very accurate answer, how can I use AI? This is how you use AI, because you use AI not to look at data or make data up. You can make queries up, because if they make mistake, the query will fail. I can ask same question to 10 LLMs parallelly and get the query that works best, or check the answers. If all of 10 giving me the same answer, then I can be confident. So there are a lot of ways that you can get an accurate answer, but also handle secrets. But that is just one way. There are other ways, like we worked with the pharmaceutical companies. You know how careful they are. They don't even want the question, the name of the molecule in the question, go to LLM. Like, how do you do that? Because at least question you would think Data we understand, we don't want to go. So what we did for them is actually created a layer called privacy preservation layer. What it did is again a very simple but a very useful component. So anything that we have in our data, we change that word and represent it by something else. Like, so the name of metformin wouldn't go, it will be XYZ to LLM. LLM will get us query back, and we'll change the XYZ again back to metformin and run the query. So that is like the one approach to just hyper-sensitive organization where secrecy is paramount. So there are always ways to find solution to the concerns. Anyway, next question.
Interesting ways. The next question is, you did walk us through the quadrant, right? The 4 quadrants. So can you provide some examples of what kind of tasks fall in those 4 quadrants?
Okay, interesting. So this one, easy actually, one-off task. Very low volume, very low variety. Maybe one of your annual report, creating an annual report. You do it once, right? So maybe you have seen many companies like these kinds of report, people actually work on it. I created this presentation, I didn't ask AI to do it, one-off thing, right? So those kinds of tasks, and we have lots of them. People do it, right? Okay, move to the next quadrant. Now here, let's take off a very high volume. I'm taking extreme examples, but it is a continuum. It's spectrum. Let's say claims processing in a small, not so big organization. I'll tell you why I'm saying claim processing. So it's a claims come in a format, and imagine there is a company focusing on one sector and process certain kinds of claims. You generally expect that there would be automation. Why? Because you process million claims, let's say, and it's a similar process, and you write code for it, right? So that's an example, but you know this really well. I don't need to tell you. What is interesting is like, okay, let's say Gen AI. Now, where you have a high volume, but every transaction is different. Let's say you are call centers. Anywhere you see team working, that is an example, most likely, that you cannot automate because every task comes up as a different one or a different variety. Support teams. Why do you need 100 people or 50 people doing certain things? I'll take actually a real example. Maybe we saw Sijan Jerome presented, right? They have like creator curation. Curation means they have like people looking at journalist data, influencer data, going online, finding what is the Instagram ID, what is the last article, what is the topic, and update that in the database. Why people you need to do it? Because so much variety, right? Every person is different, you need different search, pick other information that's missing. A lot of those examples, but where you have teams doing things are examples of where we see high variety, low volume, and potential candidate for Gen AI disrupting it. Last one, I'll take an example. I'll now scale the claim processing examples with a very high variety. Like we work with CVS, and its PBM are supposed to be one of the most complex pieces of software ever built. Why? Because claims can have like so many different varieties, and you can imagine like people would come with any different disease, so many conditions, so many different drugs, molecules that's getting played role, and then brands and commercial aspects. So the combinations are enormous. Such a high variety. You still want to write software. Now, how do you do it? Today, we spend millions, maybe hundreds of millions in creating those software. There are, I heard, like maybe 3 or 4 billion, sort of 3 or 4 PBMs in the world, and people pretty much use a variant of those because it's very expensive to build this kinds of thing. But now, in the quadrant 4, these kinds of things that we can take and look at it, okay, how do we handle that variety? And that is the flexible automation. Can we use Gen AI to take care of the variety so that it can generate code, and that's the generated automation. Yeah, sorry.
Yeah, those were really some examples that you compared it with conventional softwares versus Gen AI. What are the strategies to optimize cost of Gen AI initiatives?
Okay, interesting question, very good question. What are the strategies to optimize? Because people who have used Gen AI, they find at some stage it's expensive. Why? Because maybe they picked a case where the scale or volume is high. What happens when the volume is high, especially with respect to cost? I'm not talking about performance, but today, if you use, let's say, OpenAI or Gemini, you pay pretty much per token. And with a high volume, you, of course, consume a lot of tokens. With a retrieval augmentation, you actually add additional information in the context, and again, you pay for that, which means your cost can escalate, especially if you are not using it for 100 or 1,000 times, but million times. How do you control that cost? So one answer is, do you want to really use third party, or you can actually say that, okay, I'll take open source LLM, maybe Llama or Mistral or and there are loads available on Hugging Face, and even fine tune, just use them as opposed to external ones. Is it easy, cheap? No, because to run an LLM, you need GPUs. GPUs are expensive. But then you can go on cloud, buy GPUs. That's again expensive because you can't share them. So you have your own sort of infrastructure on which you probably do that, which is why we have actually one solution called GenAI in the box, which is a cost-effective way for organization to use LLM, where the whole GenAI stack along with sort of framework built into the box to save cost. But that is one fundamental way. Other ways are, how do you keep track of tokens, how do you summarize it? One of the things, like when we found last time that our consumption grows, then we saw what happening is that we used to attach some pushback messages into it. And so the context actually we're getting added into our conversations. Then we said that, okay, why do we need all of the last messages? Can't we summarize, reduce the token size, and then push? So those kind of things you can do. There is a lot of play there, how to reduce cost.
Sure. So these were some of cost-effective ways. But apart from that, what do you think are the measures that we can take to build trust in Gen AI systems among our stakeholders?
Okay, that is a tricky question. What we can you repeat what we can do to increase the trust?
Correct. What we need to do in order to build trust in Gen AI systems?
Right. That is a million-dollar question. Right, because there are so many concerns. Okay, I wanted actually to answer some of these questions because he knows a lot more than I do. But I'll give an actual example. Like when we started with one of the pilot and to be implemented in the production environment for a client called World Health Organization. Now you can, like World Health Organization is like an NGO, and you wouldn't expect like them to be at the forefront of technology and also equally concerned the kind of data that they manage and so on. So one thing, and we cannot really shy away from that, is an extensive testing. So technologically or architecturally, we try to make sure that we sort of give confidence, but we cannot avoid testing. And our experience is that GenAI project requires more testing than our conventional projects because there are so many ways that things can go wrong, right? And how WHO implemented the solution for 10,000 people globally that we built is one, they got the confidence when they test the application. So let's say we have a solution like a ChatGPT. What we did is, when we give the answer, we also exactly showcase what the source is, what is the information that from the source GenAI has pulled. So that is one way you can actually make sure that the answer and the source is also revealed. Like we don't see in ChatGPT, but in our business application, in fact, every application that we build, we reveal the source and the transparency and traceability. So that gave them the confidence that, yes, actually, I go to these documents, the information in the document correct, and exactly that accurately got summarized by AI. And so the way you build solution, there is an additional component that you need to take in mind to build trust, which is not just solve the problem, but how do you make it easy to test it and create confidence who would test and decide to release the application or not. You want to add something?
So primarily, there are 2-3 options that we have, right? So either someone is averse to going to cloud. That is where we can tell them, okay, if you don't want to go to cloud, there are smaller solutions that can be really deployed on your own infrastructure so that the data doesn't go out. Then there are services coming up now who claim that they are compliant to all the compliances that are there available for other softwares. Like Microsoft claims that it has all the compliances needed, like even the HIPAA compliance as well. So I think going forward, it won't be a problem. I mean, I don't see trust to be a problem going forward.
Right. I totally agree.
Thanks, Jayant. There are lots of questions still coming in.
Yeah, but we have demos also, and
yeah, so probably whoever wants to understand the architecture, we can have a deep dive later because we don't.
Right. Yeah.
Hello.
Anyway, so thank you. Bharadwaj will sort of walk us through some of the real-life use cases or demonstrations. Yes, thank you. Thanks. Thank you.
Okay. So as Jevan said and introduced me that I'm someone who should keep the efforts grounded, right? So we'll come to business, how all these technology capabilities can be applied to businesses, right? How can we help the end users to do better? Can we really help them in each and every stage, right? So we'll see multiple use cases. And please note that all these use cases are representational. So you can basically apply the similar use case in any other domain, any other function, any other business. Okay, but before going there, I just wanted to highlight two things. Please keep in mind these two diagrams. Understand what really we mean by high task variety and high task volume. And second, we talk about RAG, right? The RAG, as we know, and why it was not sufficient, and why we need to think about building a better context to provide better answers. And building a better context means we should have a unified information that is spread across your business. It can be your documents, it can be your databases, it can be in your applications and about your applications. It can be about your business processes. So we need to connect all these dots to really give a specific answer. And that's why I say, like, a typical question comes up like, is the work of developer done? Not really. We are actually giving the power to the business analysts, right? What you need to do is to really instruct the platform on how to behave, how to answer a specific question, which is nothing but logic building. And you need to instruct the LLMs to do that by providing all this context and then some prompts. That's what typically we refer as prompt engineering. Okay, so we'll start with the demos. A quick background is like, consider a user in a specific enterprise, someone who's responsible for managing the sales in a specific region, right? He's trying to understand, newly onboarded, he wants to travel. And if he wants to travel, he is going to ask questions. Okay, how do I plan my travel? What are the policies? He will get some training while onboarding. Again, he will reach out to HR function, finance function, and bug them with questions like what kind of approvals I need. Instead of that, this can be his first point of contact. So I can ask a question that gives me answer by referring to not only one source, but by referring to multiple sources, as you can see. And I can also get details on where to find more information, what is the source for the information that I am getting. So that if at all interested, I can go deeper. That saves a lot of effort, so please understand. It is not only the, if you can just pause, it's not only the effort of this guy who's reaching out to functions to get the support, but this can actually be extended to a HR function, to a finance function, and so many functions in-house. But not only that, we can expose the same solution to the clients, right? Customer service, another use case. Basically, you are doing a similar type of task that needs high variety. Because your HR guy cannot really help the customer on how do I solve a problem in a product. So you go for a customer support executive, right? Instead of that, a single agent provided with the right information can take care of all the similar use cases or of same nature. So that's the capability here. Okay, now that was about the data that we are referring to, right? The content, unstructured content. How about understanding the actual numbers, right? We can connect with databases. And I'm interested in understanding, okay, what are my numbers? I'm newly joined. How are we performing? I get a table. I don't have to really go for specific set of reports, dashboards, or open my Power BI application and create a new tool. I can ask that in English and get the information, not only tabular, but even we can have different kind of charts, graphs, And for doing all that, there is no code that is developed. Once the platform is set, it's just the user who's asking questions. So we are not going back to any BI developer and telling him to create such and such report or a dashboard, right? The tool is doing it for the end user. Okay. Next, a similar use case in day-to-day activities. I want to perform a task. I am responsible for doing a task. So what do? I find a respective system. I go on a manual. I try to understand, okay, I'm setting up a, if you can just pause, please. I'm finding out how do I introduce a new promotional offer on my e-commerce website, right? I got the steps. That is like step 1. Okay, I don't have to read through the entire manual. But that's not all. Even though I am getting step-by-step process, the context that we are passing to our platform also knows that yes, it is a Magento 2 based system. What kind of APIs are exposed to use it in a headless manner, how to call those APIs, and if there are any other parameters that I need to complete the function. So tool will actually tell me, okay, we can do this, if you can just run it. So tool can tell me we can do this, and it will tell me what key value pairs I need, right? I can either review something missing, I can add, and we can actually automate calling that API and get the configuration done. So I don't really even have to visit the back office, right? I don't have to visit any other systems. As far as we are connected with him, I can get that done. So as you can see, there are like, as per the API documentation, we need few other information. The solution is also suggesting what should be the values that I can either review or I can say, okay, wait, I want to change few things. I can change that and it will get configured. So all that is possible. Okay, we can close this. So there are, just for the time check, we can skip this and open the next video.
Yeah.
Okay. So all these capabilities, please keep in mind that we can do multiple things and helps user with the knowledge, with the data, by automating the processes. And now let's see another implementation. This is for a PBM player. So what earlier used to happen is the users used to refer to such documents and manually identify n number of parameters by reading through this document. This is a large document and around 150 different parameters need to be manually identified. And why it cannot be automated by conventional manner? Because the template is going to change, right? It's not a single template. So the conventional automation is going to fail. We cannot use that method anymore. But if we pass this document and instruct the LLM well, it can understand what the document is saying and identify information that I need, right? So what is the deductible amount? Are there any specific rules, guidelines that I need to follow? What are different things that I need to capture? Because there are so many values. If you can just run, please. Okay. You can seek ahead.
I'll just
And go
forward
to
it.
the app.
Just
Go to
forward,
the app.
forward,
Yeah.
forward.
Okay. So instead of doing all this
Forward,
manually
forward.
with a big team, we built an application where basically you upload this document. The solution actually gets all the relevant information, builds a new plan for me, and initially, as there are always questions about the accuracy and whether I can trust this information, these are the days where we are going with human-in-the-loop approach. So what we are doing is we are allowing user to review all that has been captured. We also showcase that by the percentage confidence. Tool can tell you that I'm 90% confidence with this parameter, and you need not review, and so on. And there can be, there can be misses, which you can add manually, if at all, but that like reduces 70 to 80% efforts of doing all these things manually. So yeah, those were quick few demos. There are more demos available. Please visit us at the Experience Center. And I will hand over to Srijit now on how the magic works.
Yeah, so one use case that I would like to specially mention is we have automated report generation for one of our clients. And they had this dynamic database generation. So each time they create a new customer and a new department for the customer, they would have to go back to the BI developer and create those dashboards in the Power BI, because the column names would be like numeric and like it will start from some cryptic value and numeric. So using our solution, we were able to identify and map the master name of those columns and map those together and able to generate the
Perfect.
charts now. All right, so I'll just.
Over to you.
Okay, yeah, now it's PPT time. Okay, so this is a, so RAG, as we know, as of today, lot of you would have seen this, know this, maybe some of you must have done this as well. You see the current architecture that even we had before we kind of re-architected the solution was have documents or knowledge sources ingested within a knowledge base into a vector database. What essentially we did was chunking the documents, putting it in a vector store, and retrieving it like the way Jaivan described. Knowledge sources, again, databases, we extracted the schema of the database. The schema went into, again, a vector store. We retrieved the vector store schema from the vector store, created queries out of those, and generated output out of that. What we observed was, without substantial metadata, the LLM wouldn't understand the schema very well because there were repetitive columns. The table names would be sometimes same. Not the table name, but column names would be sometimes same. So that was we were getting into issues like those. Plus, we had to deploy different solutions for different use cases a lot of time because it was not very like integratable with each other. So ultimately, we decided to re-architect that. And that was possible because of the quick development iterations going on into current Gen AI space. And our knowledge of we working on knowledge graphs from GPT 3 times, we built a solution for drug discovery like Jayant explained. So we utilized that knowledge and came up with a sort of new architecture. My drawing skills are bad, so excuse me for that. So these are kind of, so right now how it works. So there are two parts to it. One is ingestion pipeline, where we connect with all different systems that are available into an enterprise. We look for an uniqueness in the ontology. So the graph kernel that you see is not just a kernel that reads these documents, but what we identify using the generative AI LLMs itself to identify unique values, nodes, entities, things like those relationships within the data that we are extracting. So what happens is we actually open the document, identify entities and relationships, and that goes as a harmonized graph into a graph database that we have as a backbone of our solution. From that graph database, we have this vector index and full text created. So whenever a user asks question, it not only goes into a vector store to search for the unstructured content and retrieve it, but we rather have a metadata associated with that unstructured content that is ingested into the vector store as well. What it helped us to do is previously the use cases which were not possible to implement was retrieving information from a large set of unstructured documents and showing them as a search result. So identifying parameters from a document, extracting information and showing that as a search result kind of thing was previously not possible using this conventional technique that we saw before. Using this, we are able to run the cipher queries or other type of graph queries, which give us back that metadata information and tells us where this information is without going into the document itself. So once we get that information, we are able to go to the specific document and retrieve more information about the document, and then summarize that information and give it back to the user. The performance substantially increased, and the accuracy also substantially increased. That is how this ingestion graph was created. One thing that I would like to mention is there is also an option of user creating a metadata, although we kind of don't use it always, but there is an option for a user to create metadata for a particular document, which really helps because the domain expertise is always there with a business user. I'll go to the next. So this is how it works once the document gets ingested. Yeah, I'll just move here a little bit. I can see here better. All right. So what happens is the graph is an input for us now. It goes to our Gen AI engine, which actually does a work of LLM orchestrator. We do all the retrieving techniques on there. So there is vector retriever. We also have full text index for the use cases where we really need to have full text index created. And then there is a task decomposer, which decides which agent will perform this task. So the task decomposer actually looks at the question that user has put. It has this prompt database with it. So based on the user question, it decides which prompt it wants to run for this particular task. And based on this prompt, we decide which agent will perform this task. So once it goes with the agent, it will plan whether, based on the prompts and the architecture that we have done, it will decide whether it has to do reflection or chain of thoughts or any other techniques, any other reasoning techniques that it has to run through. Once that is done, we have tools available for this. This is pretty standard for any LLM agent. A lot of you would recognize this. The tools that we have are custom tools, but there are common tools as well, like search and code interpreter. The custom tools give us specifically the power to write custom code for customers as well. And this code can very well be generated by other agents as well when we use this agent chaining sort of thing. Once the tools are decided, we have the prompt template, we have all the information that we want to pass on to the LLM. Action is performed based on the input data source that we have and the context that the LLM has received along with the prompt templates. And then we have these outputs that we generate, which can be an answer, it can be a document generation, it can be a dashboard, or it can be a chart. Plus, I mean, there are hundreds of use cases that we have implemented using this architecture. So we can discuss that as on the booth as well. To someone who is interested, we can show that as well. Yeah, I think in short, that was it. But we can discuss architecture in detail, and we can take up questions now.
Any additional questions? Or can I think? Any additional questions? Then we can wait. Otherwise, I know, sorry, we might be over time.
Yeah, a few questions. First question is, how much request per minute and token per minute can be handled by your knowledge platform?
It all depends on what kind of LLM you use. For example, if you are using Azure OpenAI, based on what your consumption is, they allow, for let's say GPT-4 Turbo, they allow 250K and upwards of tokens per minute as well. So yeah, it depends which model you are using and what tier you are in currently.
So in order to confirm these, so do you use any multi-threading testing?
So if you have to see how many tokens are getting consumed, you actually can send some parameters to an OpenAI call. It gives you back how many tokens, how much the cost of each call is as well. So that is how we track it, so that telemetry goes to our backend and we analyze that telemetry.
Okay. Can you explain why the knowledge graph is required and what role it plays in the application?
Yeah. So just for a generative AI use case, you would ingest documents, you would ingest all the other information and capture that from a normal, let's say, answering bot, if I may say so. But if you don't use knowledge graphs, it doesn't give us this ability to query the data in different ways. So let's say if I have a document, I have to search within, there are thousands of documents, right? And when you use normal vector search, it would give you top 10 documents, let's say, whatever you tell it 100 documents, it will give you 100 documents. But if you have to run a query that runs into thousands and lakhs or millions of record, you would need that metadata information to give you the results back quickly. Vector will perform very inefficiently there. So that is just one use case, but there are multiple other ways to, other use cases as well.
The core idea is that your business use cases should not run in isolation.
Yeah,
all of your business use cases need business knowledge, tribal knowledge that you have accumulated over so many years of digitization journey. And if you want to make that available, because most of your use cases will need that. So where is that common platform? So this is actually not knowledge, but your business knowledge graph
it's a business
that you are creating, which is accessible to LLM. Next question could be, why graph? Why not SQL? Can we use other things? So our experience shows that LLM works far better with Cypher than SQL because then Cypher is flexible, where you have to worry about schema when you use SQL.
And creating graph is much easier on unstructured data rather than relational.
Correct. So because you have a node, you can continuously attach more and more information from disparate sources, and that also connects your then the business information, what different departments to information in IT, to information in code, information in data. You can connect that together to enrich your context. Plus, as Shijit mentioned, you can have people enriching that context further. And more importantly, I talked about your testing mechanism or tool. When you test, you find issue, you enrich metadata, because that is one way you fix the issue. Right? So that's where knowledge graphs really comes in handy.
Because there are many other positives about using a graph, so those all are inherently there.
Yeah, thank you for that use case. Would this model or tool be able to answer questions of unknown outcome based on known data?
Unknown outcome based on known data. It will, but you still have to instruct it what you want from it. It will not be just give the data. If you tell it that give me insights, it will give you insights that you don't know as well. But it always works best when you instruct it well.
Okay. In terms of integration, how do you integrate with systems such as Salesforce and Einstein?
Okay, so we have a capability in here which allows us to connect, like generate, let's say, a SQL query, a Cypher query. We can create documents. We can answer questions. There are two other capabilities that we have built. One is actually generating a payload for an, let's say XML RPC call. So we train the model to generate payloads. We also train the models if there are specific APIs that you want to generate. We train the model to generate that kind of API so that when the user asks questions, it retrieves the relevant information from the RAG system, understands what the user has asked, understands the schema of those API calls, and then builds that API, and we can just call them, and it works.
How are the prompts handled? I mean, if we need proper result, then appropriate question should be typed, right?
There are two ways. One is user asking question is very important as well, but you have system prompts where you define the behavior of the system, and there are guardrails that what a user can ask and cannot. So once you prompt or once you write system prompts or instruct the LLM to perform in a particular way, we have this facility of asking follow-up questions. So if there is an ambiguity within the LLM system or within our framework, which LLM doesn't understand, it will ask follow-up question. Okay, do you mean this? Do you want me to perform this, or is there anything else that you mean to perform? So that is how we remove the ambiguity, and then it's able to call.
I'm sure this will be helpful for everyone who's going to be integrating prompts and integrations. Last question. Given that demos may not fully capture the real impact of Gen AI on enterprises in terms of revenue, how can we in the IT services business leverage this technology to drive revenue generation?
Okay. I think it's a big question. Jayant, you may answer that.
Okay.
I pass it off to Jayant.
How do we use Gen AI to drive revenue?
Yes.
Revenue generation,
Yeah.
right? Depends on
being in IT services.
Sorry,
In IT services.
Okay, so it is specifically about IT services, not just any business. Then in IT services, there are many ways, and there are some interesting new ways that also can or should be considered, because traditionally IT services model is predominantly sort of team or effort based and work hour based revenue generation model. Gen AI gives probably would force IT companies probability to think differently, because as I told, this is an area where your effort to value creation equation would change, and we can experiment with new models which are tied to outcome, which was difficult earlier in the IT world, because where efforts were much higher and very close to the revenue, sort of the outcome or value creation. In this Gen AI world, probably because the ratio is much higher, IT companies can take a risk and allow different models of revenue generation. But also with these technology, you can actually impact businesses of your client or impact the industries of your client. Because the combination, and yesterday night, Frederick did actually put this idea together, like the internet and combining internet with industry. Today, we are exactly on the same phase. In this era, you can combine GenAI with industry, GenAI with domain, and that can open up a lot of significantly powerful ideas for your clients or for IT companies, and they can actually think very differently than conventionally.
Thanks, Jeevan.